Okay, this video is on how to draw Lewis dot structures. Now, Lewis dot structures are a shorthand way to write out the number of valence electrons that are in an atom. Now, remember valence electrons and core electrons, right? Core electrons, those are the ones that are found close to the nucleus, and then the valence electrons are the ones that are found farthest from the nucleus. They're in the outermost energy level. These are the guys that are actually going to interact with the environment, either forming bonds or gaining electrons or losing electrons or whatever the case may be. All right? So, when trying to determine the number of valence electrons, yeah, you can do the little shortcut I showed you, which is look at the which family they're in or which group they are in. But there's actually another way. Let's go ahead and take a look at, let's go ahead and say nitrogen. All right, we'll go and take a look at nitrogen. The electron configuration for nitrogen is 1s2, 2s2, 2p3, right? Because here's, if you notice, this periodic table actually has these two over here together, which is representing the 1s orbital. So we have 1s2, 2s2, 2p3. Now, another way to determine the number of valence electrons once you have the electron configuration is what is the period that the element is in. In this case, this is the first period, this is the second period. Nitrogen is in the second period. So I'm going to find in the electron configuration all of the twos. Two there, two there. Don't count, I'm not counting this guy right here. Okay, I'm counting the larger number. Okay. Now what I'll do is take these two numbers, add them together, and I get 5, which tells me the number of valence electrons that nitrogen has. So there's an additional way to determine the number of valence electrons if you don't happen to have a periodic table available to you. If I just give you an electron configuration, you should be able to tell me how many valence electrons are there. Okay? If you don't have a periodic table and you're like, well, I don't know if it's 2 or 1, just look at whatever number is the highest. Okay? Obviously, 1 is less than 2. 2 would be the number that we're looking at. So you take these electrons here and these electrons here, add them together to make 5. That gives us the number of valence electrons. Now, the task of having to draw nitrogen is, okay, well, I have a grand total of 7 electrons, which means I have 2 electrons in the middle, and I'm going to go and write them in pairs just so they're easier to count. Okay, and then here's my nitrogen, and there's 1 there, 2, 3, 4, 5. Okay, so now there's a grand total of 7. Well, remember, when it comes to electrons, I don't necessarily care about those guys. Okay, those are the inner shell electrons. Those are the core electrons. Okay, they're not going to be involved in reactions. The ones that are going to be involved in reactions are going to be these 5. Okay, whether they're going to be gaining 3 more, right, or they're going to be losing these 5, whatever the situation may be, or they may form bonds, and we'll talk about bonding soon because that's the focus of this unit is bonding. But before we get too far into it, we want to be able to quickly draw elements and atoms with the proper number of valence electrons because the number of valence electrons is going to hint as to the behavior of that particular element or that particular atom. So let's go ahead and take nitrogen. Now I know that I have 5 valence electrons. Okay, I've calculated it by drawing the atom, or I've showed it by drawing the atom. I also did this process where I looked at the electron configuration. Okay, now all I need to do is draw my dots, and the dots, each dot's representing the outer shell electron or the valence electrons. So I'm going to go ahead and start with 1 right on top. Okay, that's 1, and I want you to go clockwise until you've got the number of valence electrons done. Hey, that is the electron dot structure for nitrogen. Okay, you may hear me also say Lewis dot structure, Lewis dot diagram, or just Lewis structure or Lewis diagram. Okay, but this is it. That's all. That's all you're doing. Okay, it's pretty easy. Let's go and take a look at the next one. Okay, go ahead and clear this, and let's take a look at how about fluorine, aluminum, and potassium. Okay? So, let's go and look at fluorine first. So I can do one of two things. If I have a periodic table, I can just count the rows. This is 1, 2, 3, 4, 5, 6, 7, 8. Don't count that hydrogen right there. Okay, that just gives me the number of valence electrons in that column. Now, you're only going to be responsible for giving me the Lewis dot structures for your alkali metals. Okay, and I'll go ahead and indicate that right now. Your alkali metals, your alkali earth metals, your metalloids, your nonmetals, your halogens, and your noble gases. Those are the only ones that I'm going to have you need to give me a Lewis dot structure, a Lewis dot diagram. Okay, transition metals, poor metals, the lanthanide, actinide series, don't even worry about them. Okay, so again, Lewis dot structures for alkali metals, alkali earth metals, metalloids, nonmetals, halogens, and noble gases. Those are the guys that we want. Okay, now that I've completely destroyed my drawing, let's go ahead and continue on. So my first one was fluorine. Okay, if I want to draw the Lewis dot structure for fluorine, I know that there's 7 electrons. I'll start off with 1, 2, 3, 4, 5, 6, 7. Done. That's it. Aluminum. There's the third column. But remember, the other way I can do it is if I took the electron configuration, which is right. I just did a shorthand electron configuration. I could take, here's my 3s. There's 3 valence electrons. So 1, 2, 3. This is my that's my Lewis dot structure for aluminum. That's my Lewis dot structure for fluorine. And let's go ahead and do our potassium, which is an alkali metal. Ready? Done. Nice and simple. Okay, remember, Lewis dot structures are just showing us how to draw the number of valence electrons and make it nice and easy. Because if we know how many valence electrons there are, one, we can kind of predict the reactivity of that particular element, but also, or that atom, but also it'll tell us in the cases of covalent bonding how many bonds it'll form. Okay? Because remember, we all want to have, or all these different atoms, they all want to work to have 8 electrons. And the whole point of bonding is to get 8 electrons, whether that be ionic bonding or covalent bonding. And like I said, we'll get into those in more detail in the future.